Good afternoon, my friends, my viewers at home, and for every student around the world. My name is Andronali, the Bazooka Prophet, and here again we are here trying to work on what we call NERNST equation, which is a continuation of what we have started under electrode potential. So today we are going to be talking about what we call the NERNST equation. Now the question now is, what is NERNST equation? Very simple. NERNST equation is the equation which is used to calculate for what? For electrode potential, for cell potential, or the electromotive force for what now? For the concentration and the partial pressure. The partial pressure that are not in standard state or value. Now, it will be very interesting for you to know that that the next equation was first stated by a man called Walter. Let me spell Walter Nernst. This man is one of chemistry or one of the great scientists that we have in chemistry, and not only for his wide range of idea, it will also be noted that this man called Walter Nernst was also the first person to state for us the third law of the third law of thermodynamics, which we see like in our subsequent videos. Now, the formula for next equation generally is given as this, which is E is equal to E naught minus RT over NF ln Q. Now, we are going to explain, or like I will tell you what each of these parameters stands for. For example, the E stands for the electrode potential under the non-standard condition, and the E naught stands for the standard electrode potential. Of course, you are aware that this arrow is a gas constant, and and in this case, we make it of it to be 8.314 joule per mole per Kelvin. Then your T, which is temperature. We have our N, which the N stands for the number of electrons that are being transferred in the redox reaction. Then F, which is Faraday, 1 Faraday or 1 farad is equal to 96500 coulomb per mole. Then the Q, which stands for the reaction what? Quotient. Now we move swiftly to two major formulas that are used. And the first formula is when like I would have been able to tell you how to derive all these, but there's really no time for that. There's really no time for that. So, but basically, this is when you resolve all these things, you should be having the next equation to be in two phases, whereby at case one, whereby the temperature can, like at any given temperature, you get me now. While at a constant temperature, which is at room temperature, which is at 25 degrees Celsius, this is the formula that we make use of, which is E is equal to E naught minus 0.0592 over N log Q. You get why this one is E is equal to E naught minus 0.000198 over N log Q. This T stands for at any given, meaning if they give you a question and they tell you that the temperature is at so and so temperature, you use this formula. But when you know that the temperature given to you is at 25 degrees Celsius, which is at room temperature, which is common in exams, this is the formula that you make use of, which is most of our questions will be centered around this area. So move to some examples. Example one. So move ahead. So we solve one question, solve the next question, and I believe that with my explanation of this question, you can also solve any question of your choice under this area. So move ahead swiftly. So solution, we solve it in the gradual process. Now, they've already told us it's at 25 degrees Celsius, so you know what to do now, which is the next equation, which is to use E is equal to E naught minus 0.0592 over N log what now? Q at the first step. Now what do? We move straight down to calculate for our E naught. And calculate for our E naught is E as I've already done before. the direct method here will help us and make things much more easier for us. So what do we do? Now we come here that okay, we already have this our cell notation. Here is the Sn to give me Sn2 plus, and then we have the electrode potential for this case here to that turn to plus, which is plus 0.14 volt. Now, and to balance here becomes plus 2e minus. That's for oxidation. While for reduction, here becomes, which is for, we have silver ion to give me silver, because we are not changing anything. Here still remains, which is 2 plus e minus here. Here we now remain as plus 0.779 volt. And when we do it, I believe that when you add these two up, you should be having to be 0.91 volts. 0.919 volts. Now the issue now is that you must know how to balance a redox equation. Now the electron here is 2 and here is 1. What do? You cross multiply. So you multiply here by 1, which still remain this, and you multiply this one by 2. So here becomes 2, and here now becomes 2e minus, while here become 2. So when we, so that at the end of the day, this electron here and this one here can cancel out, but don't forget that the number of n here will now be 2, because it is the number of electrons that is being transferred. So we add them up together. So here now become Sn plus 2 silver ion to give me 2 silver atom plus Sn2 plus. So with this one here, I feel that most of the answers can be solved. Now we already have for our E naught to be 0.919 volt. I already have for my N here, my N here, which I already know, and my N here is already 2. The next one is only for my Q. Don't forget that your Q, which is your reaction quotient, simple, is your product over your reactant. And meaning you are trying to, because of what you are giving in an aqueous solid, which is the anion here, is done between here and here. So the Sn here, which is the tin2 ion here that was given to us, was equal to 4.5 times 10 raised to the minus 3 over the product here, which is the silver ion. The silver ion here was what now? 0.11. But remember that these two, if you have heard of what we call chemical equilibrium, you should know that when I'm having something like 2 silver like this, if I have to do it in terms of chemical equilibrium, it becomes the power, the silver 2. So here now becomes 2. And when you do the division sign, you should have your answer to be 0.371 and 0.3719. Now we move to the formula that says E is equal to E naught. My E naught I have here was given to me. My E naught was 0.919 as 0.919 minus 0.0592 divided by my N here is 2, and log, which is, remember that it is a log 10, to be 0.3719. So you continue. Now the E here is not equal to 0.919 minus, when you resolve this one, which is my 0.0592 divided by 2, you should be having it to be as 0.0296 times the log of this value here should give me that z minus 0.4296. So here now becomes which is now equal to 0.919 minus, when you do the multiplication, should be having it to be minus, that's minus 0.0127, so that you are aware that 0.919 minus minus and minus will give us plus, that will give me 0.0127. Final answer of the E should now be equal to 0.9317 volt. That is the final answer. You will begin to see that it is as easy as it is. Very simple. Follow the rules, and that's how you get it clear. So let's solve one last question. Okay. So we enter the next question, which is also a very simple one. With the rules that I've told you can be addressed. So we'll move here swiftly, which is solution. Very easy. Now, it's calculate the cell potential value for what you can see here at. You need just see this temperature, and you know that what you're looking for is like a next equation that you use. Just come here to say your E is equal to E naught minus 0.0592 over n log your Q. As a, so what do? You break that into pieces. Now, to get for your E naught, which is your standard electrode potential, what do? You come here, you follow the cell notation, which is zinc to give me zinc ion. You can see here, and the standard, of course, you know that definitely you are able to turn. So when you turn it, the sound will change. Yet to zinc ion to zinc, and then you're not having for the, because of your cell rotation, you're not having from zinc to zinc ion, as I already explained to you earlier. So here becomes plus 0.763 volt. Then from ion 2, so ion 3 ion to ion 2 ion. Now, don't forget that it still remains where it is. So we're having from ion 3 to ion 2, the value still remains the same, which is plus 0.77 volt. And of course, we balance this reaction here for oxidation. Electrons are added to the right hand side, which is 2E minus. Here added to the left hand side, which is plus E minus. Now, of course, you are aware that you just add them up, normal, which when you add it up, what you should have should be 1.533 volts, which is 1.533 volts. So here becomes 1.533 volts. As you can see right here, then you, now to balance this, to add them up, to have your overall, you make sure that the electrons are the same. Here you're having one electron, here you're having two electrons. To multiply as we did earlier. So here becomes times 1, here becomes times 2. So times 1, which here remains the same. Right, times 2, here becomes 2. Here becomes also 2. Here becomes 2. So at last, this one will cancel this one. But don't forget that your N is also 2. But the number of electron transfer there is 2. So you add them up. So you're having zinc plus 2Fe3 plus to give me zinc ion plus 2Fe2 plus. Now to get for your Q, you are aware that your reaction quotient is equal to your product over your reactant. Come here, for your zinc ion, for your zinc ion here is 0.5, right? Multiplied by your ion 2 ion here, bracket 0.15, and it was all square, over the ion 3 ion here was bracket 7.2 times 10 raised to power what now? Minus 6, the same all square. Yes. But when you times and you multiply, you should be having it to be 2.17 times 10 raised to power 8. So move straight away to the cell potential, which is E is equal to, the standard there was what, 1.533 minus the 0.0592 over 2 multiply, which is log 2.17 times 10 raised to power what now 8. So here becomes 1.533 minus, divide this thing, we have 0.0296 times the log 2.17 exponential 8 should give me 8 point, okay, let me see, 8.3365, 8.3365, yeah, 8.3365. So I will come here, then we add these two up. So we add it up, we should be having the E to be equal to 1.533 minus, when these two are added up, 0.296, should be having to be 0.24, yeah, 0.2468, that's 0.2468. So when we subtract minus us 0.533, we have in the final answer to be 1.286 at 1.2862 volt. That is the final answer. And on that note, I want to appreciate you guys for your time, and please subscribe to get more updates from us. Remember, humble self and Adrenaline the Biological Prophet. Wish you all the best. God bless you.